Okay, so now we're going to look at the sum formula for tangent. So the way to go about this, okay, don't write this. You could actually write it as sine of alpha plus beta over cos of alpha plus beta. Apply the formulas for sine of a sum, cos of a sum, and essentially try to rewrite everything in terms of tangent of alpha and tangent of beta again. Okay, so there's a proof of how that's done in the book. So if you're curious, you can actually take a look at it. And right now I'm just going to write down the formula. So it's going to be tan of alpha plus tan of beta. So if it's a plus here, it's a plus there at the numerator. But in the denominator, it's the opposite. If it's a plus, it's going to be a minus tan of alpha, tan of beta. And if it's a minus here, it's going to be a minus there and a plus here. And if you're curious, the proof is on page 710, 711. And essentially they use the trick I've just shown you. You convert your tangent of a sum into sine of a sum over cos of a sum, and you rewrite everything in terms of tangent and of alpha and tangent of beta. But what I want to do with that is look at an example from the book. So you essentially have a vertical pole here. Okay, so this is a vertical pole. Okay, and it's fixed with two wires that are related to the ground. So there's the ground here. Okay, and they're attached to the pole at this point, and this measures 50 feet. Okay, so there are two wires, like I said. So there's one that just goes like that. Okay, it's attached at a height of 40 feet. Okay, and there's another one that's attached to the top of the pole, and top of the pole measures 47 feet. Okay, and what we'd like to know is the angle between the wires. Okay, so I have two solutions. Okay, one which I find is actually the easiest one and doesn't involve the previous formula, and the second one is the one you find in the book that does involve the formula for the tangent of a difference. So here's my solution. Maybe you want to do this by yourself too. This might be a good idea to try to tackle or at least start the problem a little bit by yourself. Okay, and then compare it to what I have. Now, there are other angles we can label here. Maybe this one, beta, the angle between the ground and the first wire and the ground with the second wire. Maybe this is alpha. Okay. And clearly here, theta is going to be alpha minus beta. So if I find alpha and beta, I'm good. Now, for alpha, it's not very difficult to find what the angle is, because if this is alpha, we've got a right triangle here with a height of 47 and a base of 50. And basically we can recover the angle just with simple trigonometry. So 47 is the opposite side, 50 is the adjacent side. So we're working with tangent here. So tangent of alpha is 47 over 50, which implies that alpha is the arctan, or the inverse tangent function of this number. And I've set my calculators in degrees. Well, actually, I didn't calculate this exactly. I just kept it like that, and I'm going to calculate everything in the end altogether. For beta, it's very similar. The only difference is that the height is 40, but the base is still 50. So tan of beta would be 40 over 50, which implies that beta is the arctan of 40, or this is 4 over 5. We could just write 4 over 5 of 4 over 5. Okay. And finally, remember that theta is alpha minus beta. So theta will be alpha, which is arctan of 47 over 50 minus the arctan of 4/5. And if you set your calculators in degrees, you will get 4.57 degrees. If you set it in radians, your answer is going to be in radians. So about 4.5 degrees. So this is solution one. Honestly, I think it's the easiest solution. But there's a solution that can involve the difference formula, because theta is the difference of alpha minus beta. And similarly, we could say that beta is alpha. That's the other thing, right? We could say this, but we could also say that beta is alpha minus theta. So if we want to find beta, we can use this to get another type of solution. So this is what we're going to do here. So solution 2. So we're going to use the fact that beta is alpha minus theta. Okay. Now, if I calculate the tan of beta, that's the same thing as the tan of alpha minus theta. And tan of beta is known, right? It's tan of beta is 4/5. Okay. This is exactly what we've done here, right? So we have to actually use part of the work in solution 1 here. Tan of alpha minus theta. Theta is unknown, so I'm going to get an expression for my unknown here. So using the difference formula for tangent, this is going to be tangent of alpha minus tangent of theta over 1 minus tan alpha tan theta. A plus, there's a plus. If this is a minus there, it's plus there. And then tan of alpha, so again here I kind of have to use my work also from solution 1. So as you can see, this solution is not very super efficient, but it's kind of cute because it uses the formula we just introduced. Tan of theta is unknown because theta is not known to me. This is 47 over 50 minus times tangent of theta. So as you can see, basically what I get is an equation involving my unknown theta, and I'm going to solve that equation. So it's this, right? So I equate, if you look at both sides, you get this. And then we're going to solve for tan of theta eventually for theta itself. So how do we solve for tan of theta? First, let's get rid of the fractions. Okay, so I can use the basic principle. If I have a over b equals to c over d, I can multiply by d on both sides, by b on both sides, right? Essentially multiply by bd and multiply by bd, and I'm going to get ad equals ac. So essentially you can sort of cross multiply. So multiply a with c, c with b. So let's do that. So this is going to be 4 times 1 plus 47 over 50 tangent of theta equals to 5 47 over 50 minus tan of theta. Like that. So if I multiply on the left hand side, I get 4, and 4 times 47 over 50, that's 3.76 exactly. This is going to give me 4.7 here minus 5 tan theta. So my unknown is here and here, so I'm going to regroup those two terms and regroup the other terms on the other side, so like that. and this is going to give me 8.76 tangent, essentially adding 3.76 with 5. And tangent of theta will be 0.7 over 8.76. And finally, to get theta, I will take the arctan of that. So I guess this solution, it has the advantage of involving only one arctan evaluation. But since we've got a calculator, it's not such a big deal actually to do 2 arctan evaluations like I did in solution 1. So if you checked the value of this, you should get the exact same angle, so 4.57 degrees approximately. Again, that's because I set my calculators in degrees. So it's kind of cute because it uses the sum, actually the difference formula for tangent above. But clearly, solution number 1 is way faster and way more efficient. In particular, we need to use all the work in solution 1 in solution 2. So anyway, all right. So so that's it for that section. And after that, we're going to look at solving trigonometric equation in section 9.5.